Hi everyone, join me in answering question 5 from a 2024 GCE Mathematics paper 2. So question 5 has got two parts, A and B. A is on calculus, B is on computers. So starting with A, evaluate the definite integral from -1 to 2 of 6x to the power 5 minus x to the power 4 plus 3x squared minus 1 in brackets with respect to x. So 3 marks for this part. On A, we are going to start by first of all getting the integral of the function given 6x to the power 5 minus x to the power 4 plus 3x to the power 2 minus 1. So for the first term, 6x to the power 5, we are going to add plus 1 to the index of x, then divided by the new index 5 plus 1, then minus x to the power 4, so we'll add plus 1, then divided by 4 plus 1. Then the next term is plus 3x to the power 2, so 2 plus 1 divided by 2 plus 1. Then the last term has minus 1. So we introduce x to the power 0. So this is because x to the power 0 is 1. Any number, any variable to the power 0 is simply 1. And 1 times 1 gives 1. So the index will be 0, then plus 1, then divided by the new index 0 plus 1. So now the limits that we are considering are running from -1 to 2. So now we simplify the new expression that we've come up with. So we are going to have 6x to the power 6 over 6, then minus x to the power 5 over 5, then plus 3x to the power 3 over 3, then minus 1 times x to the power 0 plus 1, that just gives x, then over 0 plus 1, that is 1. Then the limits are from -1 to 2. So 6 into 6 can simplify to give us 1. 1 times x to the power 6 gives x to the power 6, then minus x to the power 5 over 5, then plus 3 into 3, that is 1. 1 times x to the power 3 gives x to the power 3, then minus x divided by 1, that gives x. The limits are from -1 to 2. For the next stage, we are going to substitute 2 and -1 into the function and then determine the difference of those two substitutions. So this is going to be done as follows. So starting with 2, substituting 2 into the function gives 2 to the power 6 minus 2 to the power 5 over 5, then plus 2 to the power 3 minus 2. So we are going to determine the value from this. Then this is going to subtract with the substitution of -1 in brackets to the power 6 minus -1 again in brackets to the power 5, then this is over 5, then plus -1 to the power 3, then minus -1 in brackets, and then we close square bracket. So the first substitution of 2 gives us the following. So if you use your calculator, 2 to the power 6, then minus 2 to the power 5 divided by 5, then plus 2 to the power 3, then minus 2. This here gives 318 over 5. So the first substitution gives 318 over 5, and this will subtract with So the next substitution is -1. So -1 to the power 6 minus -1 to the power 5 over 5, then plus -1 to the power 3, then minus open bracket -1. So this here gives 6 over 5. So minus 6 over 5. Working out the two fractions gives the following. So this is going to equal to common denominator, that is 5, and 5 into 5, that is 1. 1 times 318 gives 318, then minus 5 into 5, 1. 1 times 6, that gives 6. Now 318 minus 6, this gives a 312, then divided by 5. Now using a calculator to find the value of 312 divided by 5, this here is 62.4. So this is the value of what we've been given on A. Moving on to B. On B, the question reads, the flowchart below shows the steps that are carried out in calculating and displaying the area A of a sector given its radius r and angle of the sector theta. So the steps that are shown starts with the start box, then enter r, theta. Then in the decision stage, we've got a question there: is r less than 0? Yes. Print error, r is not valid. Then no. Area is equal to, in brackets, theta over 360 multiplied by pi, then multiplied by r to the power 2. Then the output has print A, then stop. Now the question is, write a pseudocode corresponding to the flowchart program above. For solution on B, the pseudocode that we are going to come up with is going to have almost the same instructions as the flowchart given here. So the only changes are going to be on the decision stage. In the decision stage, there is a question: is r less than 0? So for the code, it is going to be if r is less than 0. For yes, this is going to change to then. Then for no, this will imply else. Then between the action box and the output, we are going to have who and if. So those are the only differences that are there. So for the solution, we are going to write the code as follows. Since the flowchart starts with the stage start, so our code also is going to have start. Then the next stage is enter r, theta, an entry stage. So our code will also have enter r, theta. Then the next stage is the decision stage, where there is a question: is r less than 0? So we are going to change this to a statement: if r is less than 0. For the outcome, yes, this changes to then. We show the outcome: print error, r is not valid. Then for the other outcome, no, from the decision stage, this here is going to be shown as else. And then we go to the next stage, which is the action stage, where there's the formula: area is equal to, in brackets, theta over 360, where there's multiplication of pi. Then that pi is also multiplying with the r squared. So that is the action stage. Then before we go to the output, print A, we show end if. End if, then print A, which is printing the area, and then the last stage is stop. So this here is the pseudocode for the flowchart program that is given above. Thank you so much for watching this video.